are from MSA1 of KSA Group for subject Computational Technique for Biostatistics, SBS 2033. Our team consists of two, which is me, Ani Sofia binti Azman, and my partner, Nur Adila binti Ali. We are going to explain about statistical analysis from Journal of Clinical and Diagnostic Research.
Assalamualaikum. Today, I would like to introduce to you a little bit about our statistic data from Journal of Clinical and Diagnostic Research. This journal article is about assessment of obesity and its association with the physical activity in medical students. This descriptive cross-sectional study was conducted in Department of Biochemistry, SVKSMI, and RC by Sumendip Vidyapith. These medical students from first year MBBS course was included in the study, but only 138 only take part to answer the questions given. The study focused on relationship between body mass index (BMI) associated with physical activity. We have three different activities: at rest, 30 minutes of walk, and 30 minutes of jogging. This data was compiled in Excel worksheet, and it also analyzed in Minitab software. Chi-square and Pearson's correlation tests were applied and alpha error was set at a 95% level.
Next, we will proceed with data from journal. This table shows a raw data of students' distribution as per their BMI. The BMI values of 147 students has been recorded. This is the distribution table of students according to their BMI group and physical activities. There are three available variables, which are having no activities, 30 minutes of daily walking, and also 30 minutes of daily jogging and gym activities. The null hypothesis in this study is the variable having physical activities and BMI are independent, while the alternative hypothesis for this study is the variable having physical activities and BMI are not independent. The study claimed that physical activities and BMI are independent.
After we know the data, now we proceed to the main part, calculation. To find the chi-square independent test, we can use two methods. First, using Minitab software, and second, using calculated by hand. First, let me see the first method using Minitab. Firstly, after open your Minitab, we can see the stat icon above on the left side. Choose tables and then choose chi-square test for association. And then one table data will come up. First, you can choose summarize data, and then at the column section, we put all the group, and for the row, choose physical activity. And then click the statistic button below. Choose chi-square test, display counts, display marginal, and expected cell count. Lastly, click OK. And then the result will appear. We take the Pearson's value 58.081 as it was the most accurate to be X squared. The second method we calculated by hand, which means we can use Excel for more convenience and accurate work. For chi-square independent test, we need to do a contingency table. As you can see, this table only need observed frequency and expected frequency. Without these two data, we cannot to continue fill the added data in the table. For your information, observed frequency is data that given in the question, while for the expected frequency, we need to find it using its own formula to calculate. This is expected frequency formula for each cell. Let's take a look for one example. For example 1, we use cells in row 1 and column 1. 51 times 31 divided by the sample size 138. It will give an answer 4.804. Although we have two different methods to use to find the result, but still it gives us the same result, x squared equal to 58.081. But we need to know, is it associate or not? So, we find another result, another answer from the chi-square distribution. We know this is as a rejection region area. X square note that we get from the chi-square distribution is 12.592.
From the result obtained, our x squared value is larger than 12.592, which indicates this value is in the rejection region. Therefore, we will reject the claim. There is enough evidence at 5% level of significance to conclude that variables having physical activities and BMI are dependent.